Okay, good morning, everyone. In the last class, we had discussed about the reactions of different metals with acids, right? With acids and the metal salts. Reaction of different metals with acids and metal salts. Can you tell me, children, why this dilute HNO3 cannot able to produce hydrogen gas when they react with metals? Anyone? Why this dilute HNO3 or dilute nitric acid cannot able to produce hydrogen gas? Yeah, man, tell me.
It's a strong oxidizing agent.
Yes, very good. It's a strong oxidizing agent. What's the role of this oxidizing agent? What happens there?
To oxidize the hydrogen in the
Yeah, hydrogen formed to which substance?
water.
Yes, it will oxidizes the produced hydrogen to water. Then what happened to this nitric acid?
It will become nitrogen oxide.
Yeah, it reduces to nitrogen oxides. Okay, so that's why dilute HNO3 cannot able to produce hydrogen gas while reacting with different metals. Okay, then what about the main condition of this displacement reaction? Anyone? The main condition for the displacement reaction to occur? Yes. Which type of metals can displace the metals from salt solutions?
Highly reactive metal.
Yes, very good. Highly reactive metals can able to displace metals from its salt solutions. Okay. So now today we are going to learn about the reactivity series. So based on this reactivity series, we can able to find out which are the metals which are highly reactive and which are the metals that are less reactive, etc. So it's reactivity series. Okay. And it's a list of metals arranged in order of their decreasing activities. Decreasing activities. This one is known as reactivity series. List of metals. They are arranged in the order of their decreasing activities. So we have to find out the different elements, different metals and their reactivity based upon the displacement reaction. We will try the displacement reactions of all metals. Then we can able to find out which are the metals they are highly reactive based upon the product form. Only highly reactive metals can displace the lesser reactive metal, right? So through this displacement reaction, we can able to find out which are the metals they are highly reactive and which are the metals that are lesser reactive. Okay, so after performing displacement reaction, activity series is formed. Okay. So you have to remember it's in the decreasing order of their reactivity. So the highly reactive one will be at the top of the activity series or reactivity series. Okay. This reactivity series also known as activity series. Both are same. So reactivity series or activity series, it's a list of metals. They are arranged in their decreasing order of activities. Okay, decreasing order of their activities. And we can, this reactivity series is formed based upon the reactions that take place in displacement reaction. Using displacement reaction, they will check which are the metals they are highly reactive and which are the metals they are lesser reactive. Based on this experiment, they will conclude the reactivity order of the different metals in the series. Okay, this is clear about reactivity series or activity series. Any doubt, children? Anyone? No. Okay. Meghna, can you please read?
I'm decreasing.
Yeah, Aditi.
What's that?
Which one?
After decreasing.
Can you please read the sentence?
It is a list of metal series arranged in order of their decreasing.
Activities or reaction. Yeah, Meghna, then you can read.
Reactivity series or activity series. It is a list of metals arranged in order of their decrease. After performing displacement reaction, activity series is formed.
Okay. Say list of metals arranged in order of their decreasing activities or reactions. After performing displacement reaction, activity series is formed. Is clear now?
Yes, ma'am.
Okay. Have you completed the slide?
Yes, ma'am.
Yes. Finished?
Yes, ma'am.
All of you, Adidev, have you completed? Okay. Then I will show the activity series of different metals. Yes, this one is the reactivity series of metals. Okay. Here you can see the highly reactive metals at the top of this series. First one is potassium, starting with potassium and its symbol is K. The next one is sodium, then calcium, magnesium, aluminium, zinc, iron, tin, lead, then hydrogen, copper, mercury, silver, gold. These metals, copper, mercury, silver, gold, these metals are lesser reactive than hydrogen. So here we are taking this hydrogen as certain reference. Okay. The metals that more reactive than hydrogen, then the metals, they are least reactive than hydrogen. So in the case of this copper, mercury, silver, gold, etc., they will react very slowly or not such reactions take place with other compounds. In the case of potassium, sodium, calcium, magnesium, aluminium, zinc, iron, tin, lead, they are arranged in their decreasing order of their activities. Okay, clear?
Yes, ma'am.
Yes. This one, can you please read the order of the metals in the reactivity series?
Ma'am,
Yes.
should we write this?
Yeah, you can write. Yeah.
Ca,
Mm.
magnesium Mg,
Mm.
aluminum is zinc is a iron S,
Mm.
Sn, lead Pb,
Mm.
hydrogen H, copper Cu,
Mm.
mercury X, silver A, gold A.
Okay, gold, AU. John Samuel, can you please repeat it once again?
potassium, sodium, calcium, magnesium, aluminum, zinc, iron, tin, lead, copper, mercury, silver, gold.
Yes. So this list of metals, they are arranged after the experiments conducted in displacement reactions. Okay. Then through the displacement reaction, we can able to identify which are the most reactive metals. So you have to learn the order of this reactivity series of metals. Do you know any shortcuts to learn this elements in the proper order? Anyone? No. So you can make any shortcut or any idea to learn this metals in certain order. Okay. You have to learn this in the correct order. This will be needed for the reactions. If there are two, one metal and one metal salt is given, if you know this reactivity series, you can easily identify is this metal can displace the metal from the salt solution. Otherwise, you cannot able to identify whether this displacement reaction take place or not. So you have to strictly learn this correct order of reactivity series of
Ma'am.
metals. Yeah,
In textbook, there is no tin.
no,
No.
tin. Okay, but tin is also included. Let me check this way, children. Yeah, in some reactivity series, this tin is also included. So you can also learn tin, okay? Yes, so this is the order of the reactivity series of metals. Have you completed?
Yes, ma'am.
All of you? Badra, can you read this different metals in the reactivity order once again?
Potassium K, sodium Na, calcium Ca, magnesium Mg, aluminium Al, zinc Zn, iron Fe, tin Sn, lead Pb, hydrogen H,
Yeah.
copper Cu,
Hmm.
mercury Hg, silver Ag, gold Au.
Okay. So among these different metals, which is the least reactive metal? Yes, which one is the least reactive metal?
Gold.
Yeah, it's gold. And which is the most reactive metal?
Potassium.
Potassium. Potassium. Have you completed? All of you? Yes or no?
Yes, ma'am.
Okay, then we are moving to the questions given in your textbook, page number 46. Melvin, can you read the first question? Page number 46.
Yes, ma'am.
Yeah.
Why is sodium kept immersed in kerosene oil?
Okay. Why is sodium kept immersed in kerosene oil? What's the reason? All of you, please.
React vigorously with water.
uh,
Yeah.
attached
tell me.
with oxygen or moist, it will catches fire. So it
Yeah.
is
Okay. Aditi, what's your answer?
They will react to moisture vigorously.
Okay, same thing, right? So in order to avoid the contact between air and moisture, we will kept this sodium in kerosene because they are very much highly reactive with air and water. That's why. So you can write there. In order to avoid the contact between air and moisture or water. Sodium kept in kerosene oil. Because sodium is vigorously react with air and water, it easily catches fire. Catches fire. Okay. In order to avoid the contact between air and moisture or water, sodium is kept in kerosene oil. Because sodium is vigorously react with air and water, it easily catches fire. Nirubama, can you please read the answer?
In order to avoid the contact between air and moisture, sodium is kept in kerosene because sodium reacts with air and water. It catches.
Yeah, it easily catches fire. Have you completed this one?
Yes, ma'am.
Okay. Have you completed? Adidev? No? Okay, okay.
Yes, ma'am.
Yeah,
Yes, ma'am.
finished. Okay. Then, Priya, can you read the second question?
Yes, ma'am.
Okay.
Write equations for the reactions of iron with steam, calcium and potassium with water.
Yeah. First one, write the equation for the reaction of iron with steam. Can you tell me, children, what will be the chemical equation for the reaction with iron with steam? Iron, it's Fe, right? Then steam, we will write H2O. Then what will be the product? Yes. Hmm?
Fe3O4.
Yeah, Fe3O4. Metallic oxide is formed. Any more side product?
Hydrogen.
Hydrogen. Iron oxide and hydrogen gas will be formed. This equation is not balanced. Try to balance this equation.
And this is second question.
Yeah, second question. First one. Iron with steam. Fe plus H2O gives Fe3O4 plus H2. Then how can we balance this equation? And Mary, can you tell me how to balance this equation? Yes.
3Fe
3Fe. Then
plus 4H2O. 2H2O
yeah, 2H2O. Then
gives Fe3O4
Hmm.
plus 2H2.
okay. Now it's balanced. Please check the number of oxygen atoms. It's not balanced, right? And Mary?
4H2O.
Yeah, it's 3Fe plus 4H2O. Okay. Then what about the number of hydrogen atom? In the right hand side. Here it is 4 hydrogen, right? Here it is 8. So
8H2.
here already 2 hydrogen atoms. So is it 8H2? Here it is 4 into 2, 8.
2H4.
4H2O.
Here it is 4H2O. That's okay. What about right side?
4H2.
Yeah, it's 4H2. Okay. 4H2. Now it's balanced. 3Fe plus 4H2O gives Fe3O4 plus 4H2. That's it. This is clear? The reaction of iron with steam. Reaction of iron with steam. So while you're writing the chemical equations, try to make it balanced, okay? Yes. Then read the second one. All of you, please switch on your videos. Yes. Aman, Fia, Aditya, Haya, Badra, Amina, Hadi, Amin, Surya, Hadedi, Savio. All of you switch on your videos. Yes. Aman, can you read the second one? Second question, second one.
Calcium and potassium with water.
Yes. Reaction of calcium and potassium with water. That's the second one. Calcium and potassium with water. Yes. So, Vishnupriya, can you tell me the reaction of calcium with water? Calcium with water. What will be the product formed?
Calcium hydroxide.
Yeah. So, tell me the chemical equation.
Ca
Ca
plus H2O
plus H2O.
giving CaOH twice.
Yeah. CaOH twice.
Plus
Is this equation balanced? Is it completed? Yeah, Vishnupriya, only calcium hydroxide is formed.
Yes, ma'am, it is balanced with hydrogen.
Yeah, plus H2. Now it's balanced, right? So this is the chemical equation of the reaction of calcium with water. Okay, calcium with water. Now it's balanced. Only one calcium at the both sides. Then here, look at the number of hydrogen atoms. Is it balanced?
H2O.
Yeah, here it is 2H2O. Now balanced. 4 hydrogen atoms, calcium. Here it is 1 calcium and the right hand side also 1. Then in the case of hydrogen, here it is 2 into 2, 4. Here also 2 plus 2, 4. The next one is oxygen. In the left hand side, 2 oxygen atom, and in the right hand side also 2 oxygen atom. Now this equation is balanced. Okay. Then next one, second question. Yeah, along with calcium, there is one, potassium, right? Along with calcium, you can also write the chemical equation of potassium with water. So, Aditya M. Nair, can you tell me the chemical equation of potassium with water? Potassium with water.
K
K,
plus H2O.
yeah, K plus H2O gives,
KOH
yeah, KOH,
plus
then
H2.
KOH plus H2. Is this equation balanced?
Uh,
How to balance this equation?
Put
Hmm.
2 for KOH.
Okay, then
Input 2 for K.
yeah. So now we can check the number of atoms. So what about the number of hydrogen? Is it balanced now? Balanced? Here the number of hydrogen atoms 2. Here it is 4. So how to balance this?
H2O, so put
2H2O.
2.
Yeah, it's 2H2O. Now it's balanced. Okay, 2K plus 2H2O gives 2KOH plus H2. What is this KOH? KOH? Anyone? KOH. What's it? Potassium
Hydroxide.
hydroxide. What is CaOH twice? CaOH
Calcium hydroxide.
calcium hydroxide. Okay, so when the metals react with water, either metallic oxides or metallic hydroxides are formed. Okay, if that metal oxide soluble in water, metallic hydroxides will be formed. Clear? This is clear, children?
Yes, ma'am.
Yeah, the reaction of iron with steam. First one, that is 3Fe. Fe stands for iron. Then H2O, it will react with steam to form Fe3O4, iron oxide plus hydrogen. Okay, then the next one, the reaction of calcium and potassium with water. So for calcium, we will write the symbol Ca. Ca plus H2O. Calcium reacts with water to form calcium hydroxide plus hydrogen. And in the second one, potassium reacts with water to form potassium hydroxide and hydrogen. This is clear now? Yes. John Samuel, can you please read the equations?
That's Ca plus
Start from
2H2O.
first one, iron with steam.
I am with him. 3Fe plus 4H2O gives Fe3O4 plus 4H2.
Okay. Then
Calcium and potassium with water.
Hmm.
Ca plus 2H2O gives CaOH twice plus H2O
H2 plus H2.
plus H2. K plus 2H2O gives 2KOH plus H2.
Okay. Have you completed, children? Yes or no?
Yes, ma'am.
Yes, ma'am.
All of you, right? Okay. All of you, please switch on your videos. Then we are moving to the next question. Third one. All of you, switch on your videos. Rifa, can you read the third question? Okay, Savio, it's
Ma'am,
okay.
I don't
Yeah.
have the book.
Why?
Ma'am, I'm outside.
Okay, okay, fine. Badra, can you please read third question?
Samples of four metals A, B, C, and D were taken and added to the following solution one by one. The results obtained have been tabulated as follows.
Okay, so the samples of four metals A, B, C, and D. Okay, just a representation of symbols, not actual symbols. So samples of four metals A, B, C, and D were taken and added to the following solution one by one. The results obtained have been tabulated as follows. I will draw the table here. Then we can discuss the questions. So here, four metals have been taken. That is A, then B, C, and D. Okay. Then the first solution, that is iron sulfate. Iron sulfate. That's the salt solution taken. Then the next one is copper sulfate. Second one is copper sulfate. Okay. Then the third one is zinc sulfate. Zinc sulfate. Then the fourth one, that is silver nitrate. Silver nitrate. And here in the question itself, they will tell us about the reaction in each case. When metal A react with iron sulfate, no reaction. Okay, no reaction. Then in the case of copper sulfate, displacement. Here it is, displacement occurs. And these two rows are remain vacant. Then in the case of metal B reacting with iron sulfate, here it is displacement reaction. Here it is displacement reaction. And here it will remains vacant. Here no reaction. No reaction. And the last one also vacant. Then here no reaction. Then here also no reaction. Here no reaction. Here displacement. Then the last one, here it is no reaction. No reaction. No reaction. No reaction. So this is the observation table given in your textbook. Okay. So before moving to the questions, you have to remember the main condition for the displacement reaction to occur. So can you tell me, children, what's the main condition for the displacement reaction to occur? Yes, anyone? What's the main condition for the displacement reaction to occur? Yes, tell me.
Metal.
Yes, only highly reactive metals can displace lesser reactive metals from its solution, right? Only highly reactive metals can able to displace lesser reactive metals from its solution. Okay, so if metal A is a highly reactive metal, it can able to displace iron, copper, zinc, and silver from its solutions. If metal B, it's a highly reactive metal, it can able to displace iron, copper, zinc, and silver from its solutions. So you have to remember this point. Then we are moving to the questions. Use the table above to answer the following questions about metals A, B, C, and D. So the first question, which is the most reactive metal? Which is the most reactive metal? You just look at the table, observe this table and tell me. Among these four metals A, B, C, and D, which metal can able to displace more metals from its solutions?
B.
How can we confirm that it's B? Your answer is right, but tell me the reason.
B displays iron, right? Iron is
In-
reactive metal.
Yeah, Vishnupriya, once again.
B displays the iron sulfate solution.
Yes.
Iron
In the case
is
of metals A, C, and D. In the case of metals A, C, and D, they cannot able to displace iron. But this metal B can able to displace iron from iron sulfate. Right? So it will be considered as more reactive. I will repeat the answer once again. When you look at the first column, okay, first column, in the case of iron sulfate, all other metals, metal A, C, and D cannot able to displace iron from iron sulfate, right? But this metal B can able to displace iron from iron sulfate. So the metal B is the most reactive metal. So you can write there for the first question, metal B. Metal B. And you can also write the reason in the bracket. Other metals A, C, D cannot able to displace, cannot displace. Cannot displace iron from iron sulfate. Iron from iron sulfate. That's the reason. This is clear, children? For the first question, metal B, because other metals A, C, and D cannot able to displace iron from iron sulfate, right? So here metal B can displace iron from iron sulfate. That means this metal B is more reactive than Ia. Okay, clear? This is clear for you? Okay. Then can you read the second question, Adidev? Can you read?
What would you observe if B is added to the solution of copper sulfate?
What would you observe if B is added to solution of copper sulfate? Here that column remains vacant, right? So you have to identify what would you observe if B is added to copper sulfate. You can tell me. It can able to displace even iron from iron sulfate. Then you can tell me in the case of the metal B, it can able to displace copper sulfate or not.
Ma'am, it can displace.
Can displace.
Yes, very good. It can able to displace. So the second one, you can write displacement reaction take place. Displacement reaction take place. So now here you can write displacement reaction. Okay, displacement reaction. Shall I move to next question?
Yes, ma'am.
Okay, so the last question. Who will read? Arjun, can you read? Switch on your videos. Arjun. Yes, can you read the third question?
What would you observe
Which one? Arrange the metals.
Arrange the metals A, B, C, and D in order of reactivity.
Arrange the metals A, B, C, and D in the order of their decreasing reactivity. Okay. Arrange the metals A, B, C, and D in the decreasing order of their reactivity. So now you can tell me which metal is the highly reactive one
B.
among this different metals. 1 minute, children. Just okay. Yes. Now you can tell me. Just observe the table. And which is the highly reactive one?
B.
Yeah, it's B. Then find out the second highly reactive metal.
A.
How can we confirm that it's A?
It displaces copper.
Yeah, it displaces copper. Only B and A can able to displace copper. That means the remaining C and D are lesser reactive compared to B and A, right? Then what about the next one?
C.
C.
Yeah, it's C. Because in the case of D, in all cases, no reaction, right? So it will be the least reactive metal. This is the order of the reactivity of different metals on different solutions. Okay. The highest reactive metal, that is B, then A, then C, final one, D. Any doubt, children, in the order of their reactivity? So the decreasing order of the reactivity of metals given here, B, A, C, D. B is greater than A is greater than C is greater than D. So for answering this type of questions, you must remember the point. Always highly reactive metals can displace lesser reactive metal. And also you have to learn the activity series. Okay, activity series. Do you remember the metals in the correct order? You have to learn the correct order of the metals in their decreasing order of reactivity for the next class. Okay. Okay, then we can discuss the remaining questions in the next class. Let me take your attendance. Just wait. All of you read this portion very well. And you have to learn the activity series for the next class. Okay. Okay, then thank you, children. See you in the next class. Have a nice day. Bye. Thank you.
Thank you.
Thank you, ma'am.
Thank you, children.